All right. Welcome, everybody. My name is Darin Grosser. Got a couple of intro slides here that we'll end up going through. But welcome to the West Michigan SolidWorks User Group, West Michigan Lakeshore SolidWorks User Group, I should say. So I'm from DASI Solutions, those who haven't met me yet. Recently, we purchased another reseller. We're based out of Michigan and Northern Indiana. We bought a company in Arizona and California. So really what that means to our customers in this area is that our tech support hours have changed a bit. So instead of just being normal 8 to 5 like most companies are, we've got a few extra hours across the country. So for those of you who are DASI Solutions customers, just know that we will have guys on for East Coast 8 to 8, and West Coast doesn't quite get the benefit unless you're an early bird, but works out pretty well either way with 12 hours of support. So I've been with DASI Solutions and representing SolidWorks for 20 years now. And basically, through all the things that we've done over the years, some of the things I'm most proud of is being a father and a dad. Father and a husband. But recently, I have been named by my kids as the Treehouse Master. And I mentioned this last time, but basically the reason is I spent 2 months of my summer building this monstrosity. So it's 12 by 12, it's a few thousand pounds, and it's 15 feet up in the air. The reason I'm showing this is because no matter what I do in my life, I always start in SolidWorks. So if you have access to it, even if you're a corporate customer, you do have the ability to have a home use license. And as long as you're not starting Joe's Tool and Die on your company's license, you can use it, practice, get stick time, build anything that you want. Evident by the project that's waiting for me at home, which is my latest, which is a bathroom project. So lay it out, make sure it fits, just like designs that you do for your companies, benefit for yourself as well. Make sure you got things that are going to look good and are concepted before you actually go to production. What we're talking about today is advanced shaping in a matter of sense. There's several features in SolidWorks that allow you to create much more complex, or to use a technical term, swoopy shapes. And it all has to do really with, of course, what the goal is. But there are many ways to skin a cat when it comes to these situations. So we can start with prismatic parts. You can work with a part that's got fairly basic geometry to it, and start to manipulate and change it using a variety of these different types of tools that we're going to cover today. So the way I've got this broken down, and I'm going to leave some room for questions at the end of this today, is we're going to start with what was actually in the request for presentation here, which is a little bit about multi-body parts. Now I'm going to talk about what they are, but also where they're going to be used in this more complex geometry creation. But for those of you who aren't aware of what they are, I want to flush that out even a little bit deeper. Now, sweeping and lofting are pretty classic tools when it comes to creating complex shapes. Sweeping, less than lofting because it has some limitations. It also has some things where you're going to have more simplified geometry as a result of it, where lofting basically is open-ended. Guide curves, profiles, as many sketches as you want to have in the circumstances there. Sorry, I just want to make sure we stay on time. The Freeform tool is one of those tools where it's basically like what people think about when they're talking about surfaces or very complex shapes. You're actually pushing and pulling on nodes, on faces, and manipulating the geometry that way. And again, depending on what you're trying to do, that's a very effective way to do it. But you can get a lot more complex results with a lot less work with that type of tool. So that's a very important one as well. And then advanced filleting. Fillets and rounds are really always regarded as just sort of a knocking off the sharp corners type of a thing. But the reality is that there are very, very complex geometry tools in the filleting capabilities as well. So starting to get into things like variable radiuses and then class A tangencies. We've started adding those the last few releases with parabolic shapes instead of just radius shapes. So we are just going to dive right into this. So first thing we're going to hit is multi-body parts. Who does use multi-body parts? Anybody out there? Okay, a few of you do. Now, a few of the reasons why I use multi-body parts. Mainly, it's when I get an assembly that doesn't need to be an assembly for me. Is that kind of the same for you guys? Okay, a lot of people who do that find that to be the circumstance. What you end up doing is, with a multi-body file especially, you end up with an assembly where you might not need it. And many times that happens because you've downloaded data. Go to GrabCAD, go to 3D Content Central, supplier websites, whatever it is, and you end up getting a featureless, in most cases, like we're seeing here, imported data, a featureless assembly, but in reality, it's still 12 files that I have to manage. It's all these part files, and there are multiple instances, and then the top-level assembly as well. So this is the type of thing where not complex geometry, but it's still a file management issue. We can save this out as a single file and still get most of the benefits, at least, of a multi-body file. Now, with a file like this is just a SOLIDWORKS assembly imported from another system or created natively, doesn't matter. But you can simply say File, Save As. And under the Save As, you change the extension, just like you would if you're exporting the file. Only one of the supported extensions is changing it from a SOLIDWORKS assembly to a SOLIDWORKS part file. Now, the beauty of that is that you can choose a few criteria here on what to keep. One of them says exterior faces. That one really doesn't yield the best results at all. In fact, it gives you a very heavy file because it's a lot of surfaces there. Exterior components is probably the least one that I would do. That would make it so that any internal components would actually be eliminated from the assembly or the multi-body part as the result. And it's a real great way to mask internal intellectual property if you're trying to send it to somebody else. Other part of that is that they don't really need to know what's on the inside of your assemblies, so it makes it much easier to deal with there from a detailing standpoint. But all components is generally what I'll do. Now, we're going to change the name on this one. I'm just going to give it a really quick name here just for the sake of, little fat finger on my name there, doesn't matter too much. But by saving this, what we're going to end up getting now is the file that is basically the part file version of that. And we call that Darin's multi-body. And the tree looks virtually identical. It still shows each of the parts. If we look at these side by side, you can see that even the material properties and colors were retained from the assembly to the multi-body part. But now I have a single file that I can manage. Yet it still looks like an assembly. It still sort of behaves like an assembly. And it's just an easier thing to deal with. Now, when we're not really dealing with just a file management circumstance for those purposes, we want to get into a little bit more of the complex shapes that you're going to get out of that multi-body. Now, this isn't the most elegant example, but it's something that I want to lead in with here because it's definitely one of the reasons multi-body exists. To do a multi-body part, it's very simple. You extrude two or more features that simply don't touch each other. Now, you can choose when you extrude a feature, if I happen to be on this face and I was sketching and drew whatever, when I go ahead and extrude, by default, merging that feature to any touched features is going to automatically happen, but you can always turn off this merge results feature. And what that would actually leave me with now is 3 individual bodies, as you can see right up here. And that always has the ability to go ahead and take that body and move it if we want to, move or copy. But you'll see that they're not touching or connected to the other. So we're going to get the ability to see and position these things separate from each other. Yet, it is still a part file. Well, one of the reasons I use this for complex geometry is that sometimes you know where you're going to start and where you're going to end, but you don't really know what's happening on the inside of it, what's in between. So this is a situation where I'll build something and then I'll use lofting or sweeping to connect those objects. Now, a classic example of this, again, is the lofted feature, and we'll talk about this a little bit more as we go, but it is basically blending of dissimilar profiles. Now, we have circle to a circle here. I'll make this further complex as we go, but when you have just extrudes like this, you only need the face as a profile within this loft. You don't need sketches, you don't need other curves. A face of any part will work just fine, and I'll show you that as we go. I'm going to pick these roughly where I want them to blend. So in this case, the lower central corner, so we can sort of get those where we want them. And you can even change this manipulator in order to align those a little bit more appropriately. When I have rectangular geometry, you'll see the results of that much more easily. Now this is just going to blend the shortest distance between these multiple faces. So this is really where you get into this area here called the start and end constraints. When we're dealing with this, we now have choices of not just touching face to face, but without the use of guide curves or any other types of sketching, we can go ahead and tell it to be directional to any type of flat sketch or edge on the part. There's no flat edges here, so normal to profile is always a very good one. This allows us to stay perpendicular to that face and even weight this so that it has to go ahead and have an angle of attack that's appropriate based on this little weighting feature here. So usually that's set to 1. It's going to give you sort of a nominal angle of attack once again, but that'll make sure that it hits this face perpendicular. Now if I set that on both sides, normal to profile, it starts to resolve itself even a little further. And just by pulling this up just a little bit, your preview is going to give you some really nice looking shapes there. We say OK to that, and then that's just going to simply make the transition of the two different sized circular or cylindrical features blending to each other. Now there's another way to do this. What I want to do on this one is just add a little bit more of a feature to it, just using a little guide curve or a sketch on this one. Actually, I don't think I've got the guide curve on this one. But you can go ahead and use these little features that we have called center lines. What a center line is going to allow you to do is make a path just by having the central path that it needs to follow. So if I want it to follow around like this and maybe sort of come back like this and maybe even come back around this direction, that's pretty good right about there. And then we'll just go ahead and make a line at the end. So now if I want to go ahead and just put these lines and arcs in particular positions, when we say OK to this, I can now do the exact same loft that we did before, profile to profile. But then what we do is we simply click centerline parameters. And I pick that path, and it will simply have to follow that as if it's a sweep. So this is sort of a hybrid, sweeping and lofting. We have dissimilar shapes, and they have to follow this path as they transition from one to the other. Again, not the most elegant thing, but that sketch is editable. It's completely something that you can manipulate. My Instant 3D turned on, that would help me. And what that gives me is some opportunities to go ahead and make some changes to this sketch that are going to move that around. All right, let's just do it that way then. So as we drag that around a little bit further, that's going to drag a little bit too far with the one we're doing right there. And you just got to play with your tangencies. Sweeping, lofting, spline features, that one's a little bit tight, so we're just kind of getting jammed up on the shape there. But when I'm working with these freeform shapes, yeah, we'll just undo both of those. How about that? Good enough. The next couple of features, though, multi-body was just kind of thrown in there. It was a little bit off topic, but good enough on that one. Sweeping is really where we start to hone in on some of the power of these complex shapes. Now, all the examples on the screen are ones that I'd like to show you here, just to give you an idea of how they're created. But these aren't isolated methods. The shape I'm making is just an example. You can really be very open-ended with these particular shapes. So the first one I'm going to hit is going to be this one over here. It's called a projected curve. And what users don't always realize is that as you're working on things, you can go ahead and create the paths that you want to follow or the features that you're trying to create just by combining existing geometry around this part. And let me find the one that I'm looking for over here. I want to go ahead and that's a good one. Rename that one while I was in the middle of it. So what you're typically doing is you're combining sketches from multiple positions. Just for the sake of time on this one, what I've got is a couple of sketches that are already created. But basically what we're talking about is a sketch on the front plane. So I have a shape, and when you look at a wire or a hose or something in 3D space, looking at it from two different directions will generally give you what those shapes happen to be. So what I've got right here, and I'm actually going to do these from scratch just because it'll make a little bit more sense for everybody. What I'm going to do is go to the front plane. And on the front plane, I'm going to sketch what this feature would look like from the front position. So I'm just going to draw it across, and again, use just a few arcs here. I'm going back and touching that point, just so you know. When you draw an arc and go back to a line, if I go back and just touch that point and pull away again, it turns it into an arc automatically. No hotkeys or anything necessary for that. A little bonus on that one. So this is what my feature would look like from the front, for example. Now, if I go to the top plane instead, this is a completely different look for the shape. Now, what I want to do is make sure that these sketches overlap each other properly. So when I go ahead and start to put each of these lines in and these arcs in, I want to make sure that they stay within each other's bounds. So in other words, this one isn't past the end of that one. But it's whichever one's shorter is going to go ahead and then truncate this result. What we're going to do is take these two flat sketches and combine them together to get a 3D result. This is under the Features tool and under Curves. It's called a projected curve. Now, there's a couple of ways to do this. There's sketches on faces, we'll do that one next, but then there's project one sketch onto the other. And just by picking each of the sketches, you'll get this really great preview of what the 3D result of that happens to be. So if we go ahead and take a look at this from a top view, you'll basically see the shape you see from that sketch. If we look at it from the front view, you see the shape we see from that sketch. And what that all gives you now is the 3D resultant, which is this complex curve in space. Now, it can be much more complex than this, but it's a great example of how these things get combined. Now, with SOLIDWORKS 2016, we can jump right to the sweep very quickly here. This is very cool. When you do a sweep, we no longer need a sketch profile and a path. You can actually switch to circular profile and just define the diameter. All you need in that case is just a path. So in this case, if I make that 1/2 inch, that's going to give us our hose right away. Everything we've done is based on those sketches. So if I take this sketch and start to manipulate that a little bit or make some changes to it, that's going to give us the ability to go ahead and edit each of these features. So once again, if I go ahead and start pulling that up or make it a little bit flatter, that's going to change what that 3D result happens to be. But in every account, what you see from the front is what it looks like from the front, and what you see from the top is what it looks like from the top. So if you're not really comfortable with 3D sketching to make those kinds of things, that's a very effective way to get that feature done. When I'm getting a little bit deeper into these kind of things, the projected curve is a great way to do it, but I also like to project curves onto the faces of parts whenever I can. So this is a sketch in the middle of space. What I want to get to on this next one here is actually going to be more of a face that's in a complex shape that we project a sketch directly onto. So on this particular one here, sorry, I'm just looking for the part I want to use. We're going to go ahead and bring up this part here, which has got a fairly complex shape. Now, in order to jump to the chase on this one, once again, I've created a sketch here, and I want to show you what that sketch looks like, because it's really just basic geometry. But I've offset some edges, and I'm using just some fillets to round off between each of those. And when you look at this, the sketch itself is on the front plane behind the part. It is just a basic 2D sketch. Under the features, curves, and projected curve option, what we're going to do on this one is we're going to project that sketch onto a face. So that label is going to be projected onto this complex face, and you see that it maps the topology of that face as a result of that. So a more complex way to get a sketch and a curve in space is now going to give you a curve that actually sits there and wraps around the top of the topology of that geometry. Once again, if you go ahead and sweep, you can jump right to it by hitting the profile, having a circular shape to it, and then just clicking on the path, which is going to give us this entire feature here. So we'll throw a little bit of a ridge around that, and then that ridge is going to give you a label or an emboss. Now, this doesn't have to merge together. If I really did this in a way that my sweep is not going to merge with the original geometry, which after I've done it, it's going to go ahead and merge. But if I reduce that or remove that, what we can basically do is use that to get to the results of having this crazy wire in space. So all you have to do is have the shape of the face or the topology or a headliner or a door frame, and you can build the trim or the types of features for those different objects. One that I've shown quite a few times, and you may have seen some different examples on the web, is this kind of a spring right here. Anybody tried to make one of these before? Okay, does anybody have a need to make one of these? Because again, I'm just going to throw it at you, but I want you to see what this type of geometry actually looks like. So with that spring geometry, what we're basically getting is the method that we use to create this curve. Now, what I've got here is just some very simple sketches. We've got an arc with a center line. That's going to be a spherical type of a surface. I have just two other lines, and then I have another one that's fairly crazy. I'll bring that up at the end. But what I want to do is make a couple of surfaces and then intersect them. And where they touch each other can also give you a compound curve. So by taking this simple center line once again with an arc on there, I'm just going to do a revolved surface. Simple 360, but it gives you that zero thickness surface geometry. The next sweep is a little bit more complex, but it's all just based on settings, so not hard to do. We're going to sweep really intricately a line along a line. Yikes, that's really scary. However, sweeps aren't always just in the base settings. When you're looking at guide curves, that's another way to inject some other control points, which we'll get to as we go. But there are just some simple options here that actually allow us to change how it follows the path or how it twists as it follows the path. So this has an option called Profile Twist. And if I set that to be a specific value, direction or whatever, in this particular one, what I want to do is just specify a twist value, which can be done in degrees, radians, or just number of revolutions. So by giving it 1, you'll start to see what it's going to do. Start to bump that up a little bit. I can make that sweep along a line and twist as many times as I want to, effectively giving us a helicoil. Now when all is said and done, I have these two surfaces sitting in space. And all you have to do is go under Tools, Sketch Tools, and Intersection Curve. And by picking these two surfaces, what it will do is give you the intersecting result as a 3D sketch. Now when that sketch is done, of course, nothing else is necessary because now we have that circular profile. So if I just go ahead and hide both of those surfaces, we can easily do that sweep operation, grab our curve, and just give it a circular profile. So same kind of thing here. We'll do a 1/2 inch on that one. So that's all it takes to make that crazy geometry. Now, to get a little even deeper than what I just did right there, what I'm going to do on this one is go back to that other sketch that I had there, because basically what I've got here is a couple of surfaces showing. This one I do not want anymore, so we'll get rid of that one. But I had another sketch waiting there, which was a center line and just some arbitrary spline geometry, just to give you an idea of just how nutty this can actually be. This is actually the one I do not want. We're going to keep this guy. So by taking this feature and doing the same type of surface revolve, what we essentially get is not spherical, but very organic data just based on a simple spline profile. But it's the same kind of operation here. Grab both of your surfaces, you can do this in either order, under Tools, Sketch Tools, and Intersection Curve, and then that will give you that resulting geometry. Doesn't matter how you do this, this is just two examples of very, very many ways that you can do this for any type of desired result. But that's a pretty wild looking sweep path right there. I don't really know of any other way I could pull that off other than this. It really does have to be the curve intersections, but it creates kind of spring I saw on the back of my 82 Cutlass. So not even quite like that, but you get the idea of what can be done here. This is round, but it could be hoses and other types of things in space as well. Now, SOLIDWORKS 2017 added a new feature here, and this is a part that I typically show, but it really shows one of the limitations removed from sweeping that has to do with just the faces that you select in order to make a sweep. So with the one that I have here, this is a pretty simple piece of geometry, but like the circular profile no longer having to be sketched on a plane to be used for any type of sweeping operations, this is a situation where if you have the guide curves that are necessary, bless you, all you really need to create any type of sweep is just a face. I don't need to pick the face, start a sketch, convert entities, and make a sketch. It's just another feature to have to manage and possibly break if things change. But all you have to do is just pick a face, start a sweep, and we just need a path for that. So the face is enough definition to get you to that point. So definitely worth noting there, but something that is easy enough to do requires less input to make that. So once again, a face, I'm just going to run a sweep, and then we'll use a curve to make that feature. Any questions so far? Anyone at all? Anyone at all? Okay. Good deal. Yes, sure.
Can you do the same thing with some
Sure. So tubing with any of these would totally be possible. What I usually get into when I'm thinking about tubing is ease of use. Now, what you can do on a sweep is you can actually draw two circles and have them nested within each other and sweep that, but that's more complex on the part. Easiest way is to just make it solid, come in here and pick the end faces, and just do a shell operation. And that way, if I just go ahead and give it a 0.1 millimeter on this one, that's going to give you the tube that you're looking for straight through it. So easier for the sweep will compute faster because there's less faces there, and then a shell is a really simple purpose-built tool. So best way to do any of those. Keep it simple. It's the same kind of philosophy I use when I'm talking about, this one's going to error out, but same kind of philosophy that I use when I'm talking about fillets. I don't put them in sketches, sometimes where you have to, but other than that, sketches should be as simple as they can be to create the most amount of geometry. You can't suppress a sketched fillet. You can only suppress fillets added to a part. So performance is an issue. I did shell twice on that one, which is why that happened. But you can't suppress a fillet for performance sake if it's built into the sketch. So I always do those as a separate operation. Any other questions on the sweeping stuff? All right. Lofting is a bit of an animal of its own, and I showed you that a little bit already with the multi-body part. But the basics for a loft, really simply, are blending of dissimilar cross sections. Doesn't matter what shapes you draw, the more profiles you have, the more guide curves you have, the more control you have. But really the sky's the limit when it comes to something like this. I'm going to show you this mouse piece. This is a SolidWorks 99 file that I've had just bouncing around in my archives for quite some time. Got a few different loft pieces, but this actually had a feature in it. See this feature here? It's errored out. It's called the shape feature. Anybody remember the shape feature? Tell me how long you've been using the software. This is SolidWorks 2017. If I click on the shape feature and hit edit, shape feature is no longer supported in SolidWorks 2010. So this file is so old, it has a feature that hasn't been in SolidWorks for 7 years. So it's been replaced by the Freeform feature, which I'll do in just a little bit, but not necessarily the reason I brought this file up. What we're getting on this file is a real example of the old days of lofted features. Now, this is a mouse, actually not unlike the Microsoft mouse I'm using right now, but it was built by using multiple cross sections. And all the user did on this one is they sketched each and every one of these sketches. So the feature that we're basically looking at right now is the trimmed version of a very ugly looking initial shape. But the purpose of this was to blend these dissimilar shapes, and all they did was sketch as many as they needed to make this happen. So that's a pretty typical way to approach a loft, though it could be more work than you need if guide curves will actually do the rest of the job in something like this. I have another file we'll bring up a little bit later when it comes to the filleting, but basically this particular feature here is also a lofted feature. The difference is somebody made that with 2 sketches instead of every interim sketch. And it was either blending together based on the dissimilarities between them, or we can put guide curves between each of those, which is where I'm going with this next. Now this is an example I show often just because it gives you the open-ended nature of what this tool actually does. What I want to do is just sketch on a few different sketch planes. So first I'm just showing the front plane, and then with the control key held, in case you didn't know what I'm doing on this one, I'm going to pick and drag a visible plane, which is going to automatically fire up the reference geometry plane tool. Now, when you control pick and drag a plane, what it does is makes a plane parallel and offset, and then fires up the tool automatically so I can add additional instances if I want to. That's the quickest way to get a plane copied in that manner. Now, with these additional planes on the screen, I just want to draw different things on each of those. So on my second plane here, we'll go ahead and start a sketch. And this first one that I'll do here, use some spline data on this one. I don't use the regular spline tool as much as I used to. The style spline is a little bit easier, but with what I'm creating right now, this is going to work for our needs. Now, for those of you who haven't used SOLIDWORKS 2017 yet, who has not used 2017? A few of you yet. Okay, Service Pack 2 was released 2+ weeks ago now, so we are right in the middle of the release cycle, so it's definitely a safe time to be able to go ahead and install. So what I've got is this sketch on the first plane. Now on the second plane, I want to sketch something specifically because it addresses a limitation that a lot of our competitors have, and that's that when you do lofting operations, each profile has to have an equal number of vertices. So what I want to do on this one is make sure that that is obviously not the case just by putting way more points in this than I need to. But again, another shape. Now, what I was mentioning about SOLIDWORKS 2017 is this thing here called a shaded sketch contour. That's why my sketch profile, when closed, filled in with this shaded feature to it. It's a nifty little thing. If you haven't come to one of our What's New presentations, you'd see why we do it there. But a little sidebar here, just because I have a nice captive audience, is when you're drawing sketches now in 2017, what you're going to get are these profiles, and they shade as you go. So as you start grabbing other features and sketching over top of those, you'll get doubly nested, which is going to further thicken the sketch shape itself. Now, why this is important is because this is a fully underdefined sketch. Kind of a weird term, but it is a fully underdefined blue sketch. However, when you have shaded contours turned on, I can grab the shaded region and I can move it without having to trick it with the copy, no copy method. It's just basically there. With it turned off, I'm just picking in space, so I get a window select. But it enables you to go ahead and grab the contour that you're looking for and even do operations like it's a bulk select for an offset sketch. So I can do an offset, and now I've got this triply nested thing happening. So pick the profile you want and it'll move around. And then the Alt key allows us to go ahead and pick further profiles. So not what I'm going to use for that one, but just wanted to show you what that looks like. What I want to do on this last sketch plane here is we're going to go ahead and sketch very similar geometry. You'll see why I'm using lines on the bottom for all of this. But I'm going to go to a 3-point arc on this one, which is clearly not the same as the 2 splines that we're using up to this point. All right, good enough. I'll leave that one on. So what we've got now are these different profiles. Now when you're doing a loft just raw like this, you're going to pick these where they're going to blend. So we hit the loft button. I'm going to pick them in their lower right area. Not necessarily right on the corner, but that is definitely the nodes that we're going to want to match up. And you'll see that it gives you the blend of these dissimilar profiles at the shortest path from one to the next. Now the shape itself is phenomenal. It's pretty unmanufacturable, but in these times where we have digital manufacturing and 3D printers, the word unmanufacturable is not quite what it used to be. So internal details can be made. We can even do that of metal and carbon fiber and still be able to produce a strong and usable part. Now the sketches are what control all of this. So if I come in here and start grabbing on sketch geometry and dragging things around, a little bit of an issue with my instant 3D today. I don't know if you're noticing that, but I should be able to drag that stuff around as I'm working on it. So yeah, it's not giving me what I'd like. So there's another reason why service packs are fun. But in that respect, what we're getting on this one here is very simply, oh, that's what I wanted, not picking the sketch. We start dragging on that sketch feature around, and what that's going to do is give us updates to the profile. So everything that we do is based on these sketches. So by picking on the feature and grabbing the sketch nodes, you'll see that that will update the loft itself.
Can it automatically go into the sketch editing then? Is that what you're saying?
For what I'm having right now,
Well, I'm on 16, so I don't know.
it would do the same thing there. Yep.
In other words, if I click on that, I'm able to do a sketch altering without having to jump into the sketch.
This is the key, is Instant 3D, this button right here.
Okay.
With this button turned off, everything you do, I pick on the feature, I'm picking it, but I have to double click it to bring up dimensions. On a dimensionless part, doesn't really make much sense, but if you double click it, it brings up dimensions. With Instant 3D turned on, a single click will bring up the features of the sketches, but it also allows you to grab on these nodes of the dimensions and drag them out real time so I can actually get changes just by pulling features around on screen. Instant 3D turned off, you double click the part, you double click the dimension, you change it, and then you hit rebuild. So Instant 3D jumps right to the rebuild when you're done with things, but it also enables those nodes on any dimension that you're going to want to modify. What's happening here is that I've used sketches for a feature, and this will be true anywhere. But by picking the feature and having Instant 3D turned on, those sketches become active, so I can easily go ahead and pick and pull those points around as well. Now, if there were dimensions there, I could just massage those numbers. Now, kind of back to what we were talking about in the sweep there, this is a part that I show often, and I basically say, look, I'm just making the outside of the skin, but every surface, and I deal with automotive people all the time, they give us one side of it. Why don't they give us the thickness? They want accurate parts, they give us both sides. Well, here, I have a complex face. All I have to do is take the opposite side and shell the rest of it away, and then what I basically end up with here is a sheet solid. It is something that has mass, it has volume, but it has a thickness to it, and it is still a solid, but it has that surfacing quality to it as we go. Now, this is just the blending of the shortest distance between these profiles. If you want to control this further, what you can start to do is add guide curves. So on my top plane, I'm just going to go ahead and start sketching some splines. Now, for the one that we're working on now, I sketched this line at the bottom on purpose so that the lower left-hand corner of this was all touching the top plane. So as I go ahead and draw this, I can connect each of these nodes as I go through. That'll give us a nice flat sketch, and then that will control how those corners blend to each other. But we also have a sketch tool that's called 3D Sketcher, and that doesn't rely on sketch planes for its definition. If I go under my sketch tool here, there's a flyout, and you can click on 3D Sketch. And this is how most people are creating wires and pipes and tube routing, by sketching in X, Y, and Z directions, not single flat plane directions. Now, with this tool turned on, what I can also do is draw splines in 3D space. So if I want to start at a point, I can pick any point I want, and you see that it's actually got a flat plane because that's the orientation that we're in. By hitting the Tab key, though, I can switch the orientations of that plane. So now I'm on the XZ plane, now I'm on the XY plane, and now I'm on the YZ plane. Now with this, what I'm going to do is just click an arbitrary space, because no matter where you are in a plane, you can go directly to any point that you want to in space as well. And you can see the delta box there showing the XYZ changes. So all I'm going to do is connect these points and finish that one. And then that gives us a spline that I can actually go ahead and take and move in all kinds of 3D spaces that are no longer controlled by a single 2D sketch plane. So it's a real fun way to deal with things, by the way. Very cool. Now that said, I have two guide curves here. So when we go ahead and run the Lofted operation, by picking where they're going to blend again, you're going to get the exact same preview that I had before. But once we click in guide curves and we start to add each one, we're going to start to drive those lower corners individually. Because this is a spline and a line, it can take many, many shapes and forms. So by clicking this opposite side, the line at the bottom is still going to be a line between the two splines everywhere, but it is very variable based on the 2D and the 3D spline that we're using to drive those. So we say OK to that, gives us a really nice look to this, and maybe get some shininess or some shading there a little bit better. But that is the same operation. I'll pick these faces, and then we will shell that out and hit the X button instead of the green check mark. And then that will give us something that's talking about minimum bend radiuses. We'll just ignore that one and barrel past it. But this will give us a nice, tidy, thin-walled, but very accurate part, right? And then if we go ahead and start doing some section views through that, there you go. Kind of validate that through there as well. So it is a nifty function which really takes any type of limitation or rule completely off the table with this. So no software rules for number of profiles or number of sketch guide curves or center lines added to this. So lots and lots and lots of capabilities there. No. Now, sheet metal loft is 2 profiles and no guide curves. And I'm as irritated as you by that answer. So I love SolidWorks. I love SolidWorks. It's my livelihood, but there are a handful of things that drive me nuts. There is less of a handful of things that drive me nuts because they are responsive and things do get added to the software. About a year ago, I had, for any of you that have put bug reports in, we tag those to your email, and when the bugs are fixed, you should get an email that says SPR number 954,000 whatever is now addressed. Last year, I got an email that said SPR number 25,000 and change. So 5 digits. We're now up to 7 digits on our SPR numbers, which are software performance reports. That is essentially, we hit the million bug mark, essentially, recently, which is really great. So 23 years does that. They are responsive. I'm going to vote for that one again when I get home, because the limitations on the sheet metal side, which he asked about, where sheet metal lofting, we can only do 2 profiles, A to B, and no guide curves can control that. So fairly limited. Anybody have questions on lofting, or anybody doing lofting that would like to make a comment? All right, everybody's good. John's running good too. So lofting, however, is best possible way to make any complex shape if you have no other options. One of the more fun ways, and the way I find that people really, users don't know is there, and you don't know what you don't know, so that's definitely valid, is this tool called Freeform. Now Freeform works on any geometry. Doesn't matter if it's imported data or native data. Doesn't matter if the face has 4 sides or 20 sides. You pick the face and we start pushing and pulling on the nodes. So I'm going to give you a couple of examples on this one of which is this nice little flashlight handle, and then this non-assuming looking part here, this little soon to be more complex looking Kohler faucet. So we'll hit each of those. But Freeform in and of its own doesn't matter what geometry you use it on. It's really just about the situation and the outline geometry for that. So I'm going to start off with just some basics about how Freeform would work. Now this is a very simple thing. It's just a 3-point arc, and we've just extruded it as a surface. So there's really nothing to it. The tool Freeform would appear by default if you're using default toolbars from installations. Many of you are pulling toolbars from previous installations. The good part about that is you don't have to re-customize your toolbars. The bad part is that new buttons won't be on those toolbars, because 2017 has new buttons, and 2016 wouldn't have been aware of those. So there are some cases where you're not going to see these buttons where you need them. But Freeform for me appears on my features toolbar, and it also appears over here on my surfaces toolbar, because it doesn't matter if it's a solid part or a surface part, import, native, or anything. So this is the way Freeform works. You pick a face or pick Freeform ahead of time, either order. I'm going to pick the face afterwards, and it gives you this little mesh look. Now, truth be told, this mesh doesn't do anything for you. It's a preview. You do have some options for being able to modify the mesh density, but in reality, it doesn't let you pick and use anything. What you do for this process is pretty simple. You go ahead and add curves and or control points. Now, when I click Add Curves, what you'll notice on my preview here, that looks pretty good up there, is there's this green line following me. Now, over on the side, you'll see that there's a flip direction button. The tab key also does that, so that'll give you a horizontal versus a, I think I'm tabbing through that one. Let's do it that way. So that's going to go ahead and give you horizontal versus a vertical, but you can control that any way that you want to. If I go ahead and click to insert a curve, that gives me a point that I can actually start putting points on. And all you have to do is hover on that curve, and I can click and add as many points as I'd like. If I add curves in 2 different directions, let's go ahead and put that horizontally, there will automatically be a point where those curves actually touch. So you'll see that there's an intersection point right there in the middle. Now, once those points are available, this is what we do with them. We just pick on them and pull them. And that's it. You can push them inward, you can pull them backwards, you can even change the tangencies for the outlying edge. Make that do anything that you want. Now, everything that I'm doing right now is staying planar. But one of the things I want you to see is that as I pick this node, you see this triad starts changing orientation. If I push it inward, it starts to tilt a little bit so that it's normal to the face that's there. So I'm going to try and get it really changing. There we go, a little bit more. You can set this up so that it actually stays normal to the surface. It always stays XYZ right-hand rule, or it basically changes based on the curve. That's just going to be an orientation that tilts and switches. But it does give you the ability to grab on these nodes and go very specifically in a direction. Now, these edges also allow you to do some interesting things. Right here it says contact, contact, contact. That means it will stay in contact with the other geometry adjacent to it. But we can also switch this up to either be tangent or class A blending to that adjacent geometry, or physically movable altogether, which actually allows me to take it and change where that surface actually was attached. So there's a ton of different things that can happen with this shape. In any event, it creates super, super, super complex geometry, which I'll turn zebra stripes on just so you can even see what that looks like. But that didn't require multiple guide curves, multiple profiles, lofting, sweeping, any of that stuff. It's all just basic push and pull. Now, in a real life example of where I would use something like that, we deal with, in this neck of the woods, not as many people as in other parts of the country, but doing product design. Now, on the shop floor here, you have product design, but it's not consumer product design, which is more, consumer-oriented, swoopy shapes, aesthetically pleasing. Not to say that these beautiful stainless steel assemblies aren't aesthetically pleasing. They're actually quite elegant. But what we do with this often is we have an art department, and that art department concepts up things that they then sell and then throw to the engineers to make reality. So in many cases, what you can do is actually go ahead and bring in images. Here I've got an image of a photograph of something. That image could have been of the entire part. It could have been just of a competitor's file, not the moral police, but could be something like that. But we want to have something here that could be an Illustrator image or a Photoshop image that we want to go ahead and be able to draw upon for the shapes that we've got there. So what I'm going to do on this one is we're going to go ahead and use the freeform features to go ahead and create a shape that maps the topology of what we see here in the image. Now it's again going to wash out up on that projector a little bit, but you can sort of see that there's a button shape that we've got there. So what I want to do is on this face, I'm going to go ahead and run that freeform operation. Now, in order to make things absolutely symmetric, we can either snap it to an existing spline that's available to us, or I can go ahead and just turn on this check mark here called symmetric. And that way what happens is as I start to place my cursor on this face, let's see if I can see that. Okay, so opposite side, you can see it to the opposite side of the plane. There's another curve that's being placed on the opposite side of that center line, symmetric about the middle of this. So you can see them coming together. Now I can take my cursor and go directly onto that plane, and it will put my curve directly in the middle of what we're talking about there as well. So kind of an interesting thing there. Now what we also do is we then go ahead and add points onto that. And the points I'm going to put on are going to be indicative of where this handle might be. Once I deselect the points button and I'm no longer in the point creation tool, now you can go ahead and start taking these points and start dragging them around. And that's again where you can make this shape whatever you're looking for, follow and map that topology a little bit just visually, and then we can make sure that these outlining edges are still going to have their nice smooth blends. So I can call that class A, or I can call it just tangent, and it will be a parabolic blend between these faces so that it is a smooth transition between the two of those. Same can be done at the bottom, though those aren't joined, so we don't need any of that type of stuff. But what that gives us is some real beautiful and clean geometry, once again, that we can then join and thicken and turn into a solid. This happened to be a surface, but really didn't have to be in that situation. Oh yeah, the faucet. This one here is pretty wicked. Now, when you look at things on the surface level, features themselves are quite discoverable within SolidWorks. You might be able to muddle through this and start figuring it out, and then the more times you use it, the better you're going to get with it. But this is an example of something I never would have thought of with this feature here, so it just bears note. I'm going to take what is a very prismatic looking part here, and we're going to add a super organic blend to the side of it over here. Now, it has to do with the freeform tool, but what I would think when I pick freeform after what I've just shown you here is that we're talking about a non-prismatic face. It's got a lot of blending to it one side to the other. And if I go ahead and add curves to this, well, those curves are straight lines, but I'm not just going to bump this face out or bump it in. That's not really the goal. So what I'm going to do on this one instead is I'm going to change the topology and make this face blend smooth to this face that it's perpendicular to. Now you can do that without adding any points or guide curves. What I do is I take these control points and I make them movable or movable tangent. But movable is going to work for all of these. What movable essentially means is as I push and pull on this face, these edges no longer need to stay in contact with their original source. Now what that means for me is as I go ahead and pick this edge down at the bottom, I end up getting a bunch of endpoints, which wouldn't have shown prior to that because as it's not set to movable, those endpoints and those tangency points don't apply. But when I set this edge to movable, what I get are two endpoints and then I get a tangency point here, which allows me to change the way that face blends. So what I like to do on this one is I like to actually take and control select all four of those. See if we can get all of them in there. And then when they're all selected, I can now move those directly off of this part. So I'm going to take those and just kind of blend them and drag them around. Now these are selectable points. I can actually snap those to the end of the geometry. See how it's actually picking and snapping to that endpoint? kind of crazy. So I'm actually detaching that face from the part, as you can see from the preview. Want to make sure that this side looks pretty good. We'll snap that guy together as well. And then I'm going to take these tangencies, which are pointing this direction. Let me get that snap back into place. There we go. I'm going to take this tangency. I want to start that over again because I did make another mispick up there. Let's go ahead and we'll get this one movable. I didn't want to move that tangency around prior to doing this because this one just works a lot easier if we just grab them before we screw around with that edge. So that little node right there is the edge problem. So I'm going to snap that back into place, but then we're going to take this tangency, we're just going to drag that around. Oh, crap. I do that just so everybody feels a lot like me. Wow, that was working. Oh, that's the edge I want, I think. Yeah, we don't want movable and tangent. There we go. So I'm going to take that point and actually blend it over in this direction. Not quite what I'm looking for on that one, but we'll get these kind of pulled in and moved over. So with that type of a shape there, what we're really looking for, that's what I want on that one. Sorry guys, I'm going to flub this a little bit just to make everybody feel good about watching me do this. But the side edge is the one I'm looking for. That's the one I want. This one's making that bottom edge move. This one I'm going to use to make the back edge actually snap together. So that's going to go ahead and run that face out that direction. And then this one over here is going to run this face out in this direction. Now, it isn't the exact same profile. You can see that from the side, it's not the same trimmed surface. But you got to understand when you're looking at a part, you're looking at what is an analytical surface that's much bigger than you see, and you're seeing the trimmed results of those. So when I go ahead and grab this and say, okay, this is what we end up getting now, is this blend flowing around the side. So without screwing this up, I'm going to do that one more time so you can see the full workflow on this. So the full face there, we're going to make all of these movable around the edges. Just got to make sure that we move the right contact. Once you have all those there, there are these 4 control points. So we'll grab endpoints and tangency control handles, and then we'll just go ahead and move those over. Now leaving these put, but picking the side edge is what gives me this handle, which I can now basically clip over here, and that's going to make that tangency linear along that edge. Same kind of thing right over here. Drag that one down, and then snap that guy into place as well. All right, so again, same type of shape. You see the final result, and that's what the geometry does around there. Okay, much better displayed in that case, but it gives you a real good idea of that, of the capabilities that those edges don't always have to remain in contact. So we got a few more minutes left here. I do want to hit advanced filleting real fast because this is probably the one that you're all going to walk out of here using right off the bat. So filleting has always been regarded as rounding. Radiuses, ball bearings, tangencies between faces, right? Filleting is no longer regarded as just a quarter round or a radius. It's very parabolic or elliptical in nature when we're using Class A tangencies or symmetries or these nice drawn out types of setbacks. So I'm going to show you these 2 examples here because they're a couple of my favorites. First example I'm going to hit on this filleting tool. We'll go ahead and use this tool here that we did in SOLIDWORKS 2017 because this is a really interesting one. I'm actually going to start this one off as a fillet feature, but what I've done, just for full disclosure here so you're in a learning environment, is you see this edge right here? That edge generally wasn't there, and it was added by putting in something called a split line. Now split lines are there in a lot of cases. Any of you that do simulation, you might put a split line into place so you can pick a very pointed load or a pointed restraint on a face, because what I have is a full selectable face. If I put a split line in, which in this case is just based on a line sketched in the middle of the part, that split line then segments this face up into 2 selectable faces. It didn't disrupt the topology whatsoever. In fact, if I go ahead and show you this without hidden lines showing, you're going to see that those faces look perfect, but you'd never know until you dynamic highlighted or selected it. But that edge being in existence gives me a control point for some fillet blends that we have going. So when you grab your fillet tool, what I'm going to do here is called a face blend fillet. And face blend fillets allow you to pick groupings of faces in 2 different directions. So if I pick a vertical, and I don't even have to pick all the way around, it sort of does it automatically. And then if I pick an opposing face up on the top, you'll basically see that it will put fillets between those faces. But what's really cool here is we have the ability to do this thing called a hold line fillet. And without typing in a radius, which is no longer defining this, what I can essentially do is pick the edge of the part here and the edge of the part here, And if I set this thing to curvature continuous, it will give us a parabolic fillet that actually goes between those edges. I didn't cut it. I didn't have to trim the face away and then loft between those, which is the way a lot of people have pulled this off up to this point. This is just the run-of-the-mill fillet tool. Now the key is this curvature continuous, because if I have a circular profile, it can't possibly hit these multiple diameters over here, or multiple radiuses. But in this case, if I do curvature continuous, it draws that off to be more parabolic. Now, bonus instruction here, 2017 added a new feature that allows chamfers and fillets to be completely, what's the word I want to use here? Interchangeable, I guess is the best way to do that. If I pick on a fillet now, even an old part, and I hit edit, there's a new button on the top that allows me to switch it from a fillet to a chamfer without changing the feature, without deleting the feature, without any of that stuff. Now again, full disclosure on this, is it's a chamfer now? The feature is still called fillet 3. Now the icon in front of it is a chamfer icon. If I pick on this fillet right here, which is a fillet 1 with a fillet icon, and go to edit and turn it into a chamfer, you'll still see that that's called fillet 1, but the icon is turned to a chamfer. The reason being right now, and this may change, but for now it's the easiest way, is that feature names also drill down into the dimension names. And if you've used those dimensions for an equation or some other type of thing, by changing the feature from fillet to chamfer, you've changed the name, and now there's this trickle effect of things that break. Now I'm sure eventually they're going to write it so it's associative, where if you change the feature name, then it's going to change the equations that are consuming that feature, but that's just a little bit more work to be able to deal with that. So cool though to be able to flip those and swap them from one to the other. Now this is one of my favorite files to show just because of the simplicity. Yes, sir.
Back on your changes,
Yeah.
chamfers or radiuses, that's only when you do a face radius, or face-to-face radius.
No, because chamfers do other things. Chamfers can be just a regular distance based on an edge selection. So if you just do a radius of a fillet, I'll put one on this side here. I will grab the face or the edge, doesn't really matter. So if I just do a run-of-the-mill fillet, in this case it's 1 millimeter, if I pick on it and then edit it, you'll see right up here we can switch it. It'll just be a 1 millimeter chamfer in that case. So we added the ability to do face blending chamfers, and could be. You seeing one that's not working?
Yeah, it was just a regular fillet or chamfer. You couldn't make it.
Interesting.
I ran into one.
I'll do one more here. This will just be a run-of-the-mill chamfer. So here's the different chamfer types. These are the two that were added, which is the offset face and then this face-to-face blending one. So that's just a run-of-the-mill chamfer there. Yep, that one's not doing it. The easiest chamfer ever. Okay, we'll make sure that that's the issue. That's what you're seeing though. Cool. Fillets will always be interchangeable to a chamfer, but that chamfer back, oh, that's an interesting one because that's a very basic thing right there. Yeah, you know, and you look at that and you go, huh? Everything else works with that? So that could very well be a bug. Could have just been a limitation that they didn't hit. But I'm going to definitely look into that one. That one's quite simplistic. You wouldn't have expected that. So with this freeform shape here, two fillets I want to show on this one that you really get a lot of capabilities out of with minimal input are the full round fillet and the variable radius fillet. Now, full round fillet is geometry specific. The geometry itself is going to give you whatever the radius happens to be, so no dimensional input. But when you go to the fillet tool and we select this last box here, which is the full round, it is essentially going to create a tangent to all three faces fillet. So the faces and the geometry determine things. So if I pick one face on the side and then pick a middle face and then pick a back face, it automatically does those tangency blend radiuses from one to the other. No, this is like a 2002 part, somewhere around there. Yeah, we had a variable radius for a while there. But that is one of those circumstances where you don't know what you don't know. And I run into that all the time. And I got floored with something last week that I didn't know. So it happens to everybody, which is really great because there's always something to learn. But the preview here, I do this on purpose with this part because this is variable thickness, it's variable orientation, it's not just a straight extrude. So it is very much a smooth blending between all of those faces. And when I'm in a competitive environment, I also point out the fact that if I did this in Unigraphics or in CATIA, they actually keep a little seam right in the middle of that face because theirs isn't a full round fillet, it is two radius fillets that are touching in the middle. They don't do the full blend. What I'm essentially doing by removing this is I'm removing that entire intermediate face. And usually those tools have to keep a small sliver face in there. It's microscopic, but it's there for programming sake. and you'd see the seam going right down the middle. So that one will change if the thickness of the geometry changes. The variable radius fillet, I'm going to do at the base of this feature, and it's all based on the edges that you've selected. So when you get into this fillet tool, it's the second one that we have over there, and it's really just a matter of picking multiple edges, and at the endpoints of each of those edges, you'll have dimensional input. So if I only select a single edge, because our fillets are automatically going to, or that's my default, is tangent propagation, you're going to see a preview around this entire thing. But before I go too deep into this, I only have one edge selected. By default, you will get dimensional inputs at the ends of those edges, and then you'll also get these little 25, 50, and 75% dots that if you want to activate them, we can turn those on. So if I wanted to go ahead and put a radius somewhere like right here, by clicking it, that's going to give me an additional dimensional handle, and where it is all based on where I drag it or where I type in the percentage of that is along the distance, so 15% for example. If you pick discretely more edges, we'll pick this edge here, and then one in the back, and then over here, what I now get is nodes at all the corners. So here we'll say 15, call this one 10. You get the previews here. The previews are phenomenal. See, this is only 1 millimeter here to 15 millimeters right next to it. Pretty sweet. Go down to a 5 on that one. We'll leave this one a 1, and then maybe make this one a 8 or 9, something in there. But the preview of this thing is phenomenal. And that is exactly the geometry that you'll get. It's going to be gray. It's going to look very variable. But you see how that blend works. It's tangent all the way around. When you pick the fillet, there are dimensions at every one of those nodes. So if I wanted to go ahead and modify this node, I could start dragging that one around independent of the rest of those. So it's a pretty neat operation, but it gives you some dynamic looking fillets for these purposes. Make that one a little bigger. It's too small. All right, so that allows for some really super cool types of blends between each of those. Any other questions that you have right now? Everybody's coming out of the other sessions there, so yes?
Any tricks in moving your multibody parts around?
What kind of trouble are you having? Tricks moving multibody?
Something and it's out in space and you want to bring it back to the center Especially round stuff.
Yeah, there's nothing to pick. The tool that I use often in those circumstances is the move tool, essentially. What it is this move copy bodies function. If I want to move something around, you pick the body, you can hit move, and it will create a feature-based feature that allows you to move things around. But what also happens is you have the capabilities. I'm going to do a copy just to get a second one here. But you also have the abilities when you hit move copy bodies to not just move them translation or rotation, you can also mate them. Now these are mates just like an assembly mate, only they don't add a mate, they just move things. So if I wanted to go ahead and take, let's see, mate settings, we'll take that face and make them concentric or coincident or whatever we want to do with those. That moves the part around, doesn't add a mate, but gets it to a spot. Probably doesn't help you with what you're looking for, but if you have a point in the part and the front plane and you pick them, you can at least bring them to each other, or the origin. Yep. This one to the origin? Yeah, I can move it, well, I can move that part of it. It's not snapping that to the origin. Yeah, is that my real origin? I guess that is my real origin. Yeah, well, that one's copied the body. Sorry, I got to turn off copy. Yeah, that one's more of a freeform move. This is the delta, so this is only going to translate it from where it was, so not to. But you could mate it to the origin, but there's no points on this one, so you kind of have the same trouble. There's no physical point on that, so yeah. Yeah, that's tricky. We should be able to. You could. I mean, that's extra work. I'm wondering if that face is actually going to move. I'm just throwing it anywhere on there right now. Make sure my sketches are showing. Sketches are on. Okay. Didn't have my sketches showing, sorry. Okay, all looks good. So we'll do another move on that one. Move copy body. Let's not copy it. And then in this case, oh, you're talking mating. Sorry. Let's do it that way. So we'll mate it coincident. That point. See, that point's not even selecting. Now, there we go. That's better. Yeah, what's it tell me? Yeah, so the sketch itself isn't on the moving body, so yeah. Yeah, that's a tricky one. Interesting, interesting. Yeah, I'd like to play with that one a little bit more. Mating improved in 2017, where when I actually pick right there and I pick right there, when I mate them, those two digitizing points will come together. That would help in this circumstance too, but this is part and step assembly, so yeah, tricky one. All right. Well, the sketch isn't part of the body that's moving though is the problem, so. Yeah, I have to have some point on the body. When you have something that's round as a donut, there's no physical point. If it was rectangular, we'd have a vertex. Yeah. Yeah. That I could, yeah. But if we want to put a physical point there, there's no physical point anywhere on this to be able to mate to that point, so. Yeah, I mean, without disrupting it, you know, and coming in there and putting in, I'm just going to draw a rectangle. It'll be a silly thing, but this rectangle will create a split line on this one. So if I say split line on this face, that's going to chop it up now into two faces, and I can pick that point now, which is on the body, and then that point, and then those would work. So that might not be the most elegant solution, but it does give me something selectable there, and then that'll move it. So, but I had to manipulate the geometry a bit to get that to go. So I wouldn't call that the greatest way. All right, so that's a little outside the bounds, but I'll stick around for a little while if anybody wants to ask any more questions. Otherwise, we've got some refreshments there. So thank you for